Hello, hello guys. Today we're discussing a new chapter, the new topic, component of blood and its function. Let's start the topic. Primarily, blood have two type of component, plasma and formed element. Plasma contain 92% of water and 7% of protein. Out of 7% of protein, they contain albumin, globulin and fibrinogen. Albumin functioning as an osmotic balancer of the blood, and globulin take part in the immunity system of our body, and fibrinogen take part in the clotting system of blood. Remaining 1% is mineral. This mineral contain glucose, fatty acid, triglyceride, cholesterol, etc. A glucose level take part a vital role in our body. So glucose can be measured in two ways, fasting and postprandial. The fasting measuring limit is less than 100 mg per deciliter and postprandial is less than 140 mg per deciliter. Now we are discussing about the formed element. Formed element contain three type of corpuscles: RBC, WBC and platelets. RBC is also called erythrocyte, and the maximum number presence in our blood is 5 million per cubic millimeter blood. So the average number of erythrocyte is present in our blood is 5 million per cubic millimeter. When this average number is disturbed, it may be increasing or decreasing. When the number of RBC increasing than average number, then this condition is called polycythemia. This polycythemia maybe occurs in the three type of condition: high altitude, exercise and fever. During high altitude, the scarcity of oxygen occur because the partial pressure of oxygen is very low and body have a scarcity of oxygen. In this condition, the body evaluate and increasing the erythropoiesis process and produce more RBC that provide more oxygen to our body. So this type the RBC may be increasing than the average, and that condition appeared as a polycythemia. As well as exercise fever also occurred, this type of condition. Now we knowing about the anemia. If the number of RBC decreasing than the average number, and this condition is called anemia. Deficiency of different type of factor may cause anemia. These are iron deficiency, vitamin B12 deficiency, intrinsic factor deficiency and bone marrow deficiency. This type of condition may reduce the production of RBC or decreasing the number of RBC in the blood than average, and anemia may be occurred. Number 1, iron deficiency. If the iron deficiency occurred, the erythropoiesis system get hampered and decreasing the production of RBC. which occurred anemia. Vitamin B12 deficiency. Vitamin B12 deficiency as well as folic acid deficiency also uh, hampered the erythropoiesis system and decreasing the production of RBC, and this type of anemia is called megaloblastic anemia. If the intrinsic factor deficiency occurred, then the body is unable to access the vitamin B12. So, absence of vitamin B12, the reduction in the erythropoiesis, a reduction in the RBC. And this type of anemia is called pernicious anemia. If any defect occurred in the bone marrow, that's also cause a reduction in the RBC. And this type of anemia is called aplastic anemia. Now we're discussing about the erythropoiesis. So what is erythropoiesis? Erythropoiesis is the process by which erythrocyte is produced from the bone marrow, and this process take part in the bone marrow of adult and child. But during fetus or embryonic stage, the erythropoiesis occurred in yolk sac and then liver, afterwards spleen. And after birth, this erythropoiesis take part in the child and adult bone marrow. So now we discussing about the subsequent stage of erythropoiesis. In the bone marrow or medulla of bone, there would be present a hemopoietic stem cell. These hemopoietic stem cell are myeloid stem cell. This myeloid stem cell get proliferated to produce pro-normoblast cell. This pro-normoblast cell further proliferating to produce basophilic normoblast cell, and then they produce polychromatic normoblast. Afterward they produce orthochromatic normoblast, next polychromatic erythrocyte, and finally erythrocyte. This is the subsequent stage. That's a myeloid stem cell produce a finally erythrocyte cell. This myeloid stem cell also produce another type of blood cell by the varies another step. So here we observe that the subsequent stages of stem cell. Now we're discussing about the which type of bone take part in the erythrocyte. In the child, the femur bone take part in the erythrocyte, and in adult, the femur as well as a vertebral column, pectoral girdle, pelvic girdle also take part the production of RBC. I mean to say erythrocyte production. Now we knowing about the shape and size of RBC. A mature RBC have a no nucleus. In the early stage, the RBC have a nucleus, but after maturation, they have a no nucleus, and it's provide more space for capturing hemoglobin, and it's have the shape, it have the size of b concave shape. It have the shape of b concave. So b concave also have a facility for diffuse more oxygen and contain more hemoglobin, as well as they can easily capillary pass through the capillary easily, capillary meshwork, and they does not hemolyzed. Now we knowing about the amount of hemoglobin present in the blood. 12 to 16 gram per 100 ml blood contain hemoglobin. The lifespan of hemoglobin is 120 day. After 120 day, they gradually degenerated in the spleen. The old RBC destroyed by the macrophage.